Back a while ago, we talked about taking a set of data that was in a table and having the graphing calculator write an equation to represent the data for us. So far, we've talked about something called a linear regression equation and a quadratic regression equation. Now we're going to add into that cubic and quartic regression equations, both of which the calculator will write for us. But right now, we want to start to determine which type of polynomial regression will best model our data. So we're going to go back and review how do you put data into the calculator and how do you look at the scatter plot on the screen. So here's a set of data that is some polynomial. And I don't know what polynomial it is yet, but we're going to just start with the data. So to put the data into the calculator, you're going to start by pressing the Stat button. And whenever we put data into a calculator, once you press Stat, number 1 says Edit. So you want to press Enter because the cursor's probably already on it. And then it takes you to a screen that says L1, L2, L3 at the top. If for some reason your calculator does not say L1, L2, L3 at the top, try cursing to the left and see if it doesn't pop up. If that doesn't work, another thing that you can try is go back and press Stat again. And if you go to number 5, it says Setup Editor. And you press Enter until it's done, and that will make L1, L2, and L3 come back. Sometimes what happens is we accidentally delete the lists, and so if that happens, Setup Editor will fix the problem for us. So what we normally do is we, in this class, are pretty much only going to deal with list 1 and list 2. List 1 will always be our X, or our input values. And list 2 will be our Y, or our output values. When you type the numbers into the list, you just continuously hit Enter. Make sure that list 1 and list 2 have the same amount of data. If for some reason you accidentally put an extra number into one of the two lists, and you go to write the equation, the calculator will spit out an error message. And your calculator screen should look like this. Once we're at this point in time, now we're going to go and have the graphing calculator write some regression equations for us. And I'm going to show you another way of doing the problem. It depends on what kind of calculator you have. The pictures that I have on this video are taken from the TI-84, which is updated with the most recent operating system. The calculator that's next to me right now is an actual old TI-83, and the way that this is done is a little bit different, so I will try to help you out. So let's talk about the new operating system. What we're going to do is we're going to have the graphing calculator write the equation and type the exact equation into the y equals function for us so that it'll graph it. So what you do is you press Stat and you arrow 1 to the right to calc. Number 4 is called linreg, that's for linear regression. And if you have the new operating system, a screen pops up that says XList and it should say L1 and YList should say L2. If they don't, you can change them. You'll notice that above the number keys, above 1 is L1 and above 2 is L2. You just use second and those buttons to change them. Frequency list, we're going to ignore. You don't need it. But what you're going to do is on the 4th line where it says store reg EQ, which is store regression equation, we're going to put Y1 in there. And the way that you do that is southeast of the Stat button. So if you go down 1 and to the right, you'll see a button that says vars. That stands for variables. Press it. Now up at the top it says vars, and then you'll see next to it says yvars. So arrow 1 to the right where it says yvars. And then number 1 says function. Press enter. You should now be on a screen where it says y1, y2, y3, y4. You are going to just press enter on y1, and now that should pop up right here. And then hit enter again so it says calculate. And then on your home screen, it'll give you the equation. If you press the y1 button, or the y equals button, you'll notice the equation has been placed into your graphing function. But what if you have the old operating system and you want to do the same thing? All right, so if you have the old operating system, what you're going to do is you're going to start the same way. You're going to press stat, you're going to arrow once to calc, you're going to go to number 4, linear regression, except on your calculator, when you press number 4, your home screen pops up with this. And then the cursor should be right here. Now, you're going to go do the same thing that the other people did with the new operating system. You're going to go, here, I'll do this for the cursor is right there. You're going to press, vars, and then you're going to arrow one to the right to y vars. And then number 1 says function. And then when you press enter, number 1 says y1. And then you're going to hit enter so it pops up next to here. And then you're going to hit enter again, and what it'll do is it'll give you the equation, and it will put that equation into y1 of the graphing function. Now, the reason we want to put the exact equation into our graphing function is because we're going to show you how to do a stat plot in your calculator, and then it'll also draw the curve, and you'll see if the curve hits the points or not. Okay, so now what you're going to do, no matter which operating system you have, you're going to press second and y equals. This is called the stat plot. In order for the calculator to draw the scatter plot for you, you have to turn the plot on. A lot of times, some of you will get an error message on your calculator when you're graphing, and it's because the stat plot is on, and I'll come turn it off for you, and then all of a sudden it graphs. Well, this is a case where we want the stat plot on. So once you get there, you want, if plot 1 says off, you're going to hit, if it says off, you're going to press enter, and then you're going to press enter again, and it will turn it on. And you'll notice that the cursor will then be on. After you turn the stat plot on, now you're going to go to the zoom button that's at the top of the screen. And I want you to find a function called zoom stat. Zoom stat is probably number 9. It's number 9 on my new operating system. Let's see. And it's number 9 on the old. So either way, it should be number 9. And then you're going to press enter. When you press enter, 2 things will happen. One is you'll see that a stat plot graphs on your calculator. You'll see a bunch of boxes. And the second thing you'll see is you'll see a linear equation being graphed through it. And it should look something like this. Well, what you'll notice is that my line doesn't go through the points. Well, if my line doesn't go through the points, then do you think this set of data represents a linear equation? Probably not. So now let's try a quadratic equation and see if that doesn't fit our points. So to do a quadratic regression, to have the calculator write a quadratic equation, you're going to go to the same place you went to for the linear regression. You're going to press stat, arrow 1 to the right to calc, but this time we're going to use number 5. If you have the new operating system, new OS. Don't forget where it says store reg EQ, you want to say Y1 next to it. If you have the old operating system, once this pops up on your screen, let's see, what should it say? Oops. I guess it just says quad reg. You want to put next to here Y1. Again, where was Y1 located? It was under vars. Arrow 1 to the right to Y vars. Number 1 function. And then number 1 Y1. So it will put that equation into Y1 for you. So the stat plot's already in your calculator. We now want to graph this new equation to see if it fits my curve. So this is what you should get for the quadratic regression equation. Now remember, a quadratic equation is in the form ax squared plus bx plus c. And when you use that storing into Y1, it doesn't store a rounded off version of this equation. It puts the entire equation in, which is better for us rather than rounding everything to nearest hundredth or thousandth or something. So now when you hit graph, because we've already turned the stat plot on and we just saved our equation in Y1, you see your little boxes, and now here's your quadratic curve. Well, does it seem to hit all the points? Not so much. So maybe this data isn't quadratic. Now let's try cubic. Again, you can now you should know where these regression equations are. They're always in the same place. They're under stat calc. Number 6 now is going to be cubic regression. Same thing. If you want to do a cubic regression on the new operating system, do not forget to store reg in Y1. Or if you're using the old operating system, when cubic reg pops up on your calculator screen, before you hit enter, go to vars, y vars function number 1, so that Y1 pops up and it'll store the equation. Now when you press graph, this is what should pop up. Hey, look, we have a curve that goes through all of our points. So maybe this data is best displayed as a cubic function. But the only way to know if the equation works with the model is to graph the scatter plot and the equation to see if it goes through the points or not. So now I introduce the n+1 point principle. It says for any set of n+1 points in the coordinate plane that pass the vertical line test, there's a unique polynomial of degree at most n that fits the points perfectly. Let me rephrase this. The original problem that we just worked with had, how many points did it have? 1, 2, 3, 4, 5. It had 5 points. It had 5 ordered pairs. That means that there would be a unique polynomial that's a 4th degree polynomial because there were 5 points plus let's do that again. If there were 4 points, then n+1 equals 4. So n is equal to 3. So the best polynomial that would fit those 4 points would be a cubic function. But our problem wasn't a cubic, or wasn't a 4th degree polynomial, it was a 5th degree. So if I did this for our problem, it would probably be best described by a 4th degree polynomial, although we found that a cubic was good. Is this always the best way to do it? No, not always. Sometimes a better way is to just graph the points and try some regression equations to see which one best fits the model. So whatever graph goes through most or all of the points is probably the best model. But this principle does say that if you have 3 ordered pairs and none of them have the same x value, then it's probably best described by a quadratic, because 3 minus 1 is 2. If you have 4 points on a graph, then the best function for it is probably cubic because 4 minus 1 is 3, and so on. In this problem, we're going to review another thing that we learned about in terms of finding equations that best represent a set of points on a graph. What polynomial function has a graph that passes through the 4 points 0, -3, 1, -1, 2, 5, and -1, -7? If we use the n plus 1 point principle, if there are 4 points, then it is best described by a cubic function. Cubic functions would be in this format. This would be the standard form of a cubic. The standard form of a quadratic, we already know, is ax squared plus bx plus c. And the standard form of a linear equation is ax plus b. So the standard form of a quartic, a fourth degree polynomial, would be ax to the fourth plus bx to the third plus cx squared plus dx plus e, and so on. Do you see the pattern? Okay, so now I'm going to go erase these real fast. Because we only want to deal with this equation. All right, so the way this works is each of these ordered pairs is x and y. And I'm going to put this y equals at the end because remember that it doesn't matter with equality if it's y equals at the beginning or the end. For the purposes of what we're doing, we want to put it at the end. I'm going to plug in 0 everywhere I see an x, and I'm going to plug in -3 for y. So I'm going to have 0a plus 0b plus 0c plus d is equal to -3. Yes, I'm going to leave the a, b, and c there because what we're going to do in a few minutes is we're going to create a matrix. We did this when we did quadratic regressions. Now I'm going to plug in the second equation. I'm going to plug in 1 everywhere I see an x, and I'm plugging -1 for y. So I'm going to get 1a plus 1b plus 1c plus d is equal to -1. Remember, even though you don't see it, there's a 1 in front of that d. Now I'm going to plug in 2 and 5. So y is 5, x is 2. Now I got to do a little bit of work because 2 to the third power is 8. 2 squared is 4. And then this is just 2c plus 1d is equal to 5. My last equation, I'm going to plug in a -1 everywhere I see an x, and y is -7. -1 cubed is -1. -1 squared is +1. And then c times -1 is -1, and then 1d is equal to -7. All right, this is going to be put into a matrix where all we use are the coefficients. So the first row, it's going to be 0, 0, 0, 1, -3. The second row is going to be 1, 1, 1, 1, -1. The third row is going to be 8, 4, 2, 1, 5. And the next row is going to be -1, 1, -1, 1, -7. When we go to put this in the calculator, we need to know how many rows and how many columns this matrix had. It has 4 rows and it has 5 columns. So we're going to put a 4 by 5 matrix into the calculator. Remember, to put a matrix in the calculator, you're going to hit second, x to the -1st, that's the matrix function, and then you're going to cursor over to edit. And we're only ever going to work with matrix A, so you're going to hit enter, and you need to change the dimensions because the top of your calculator probably says something else. So don't forget to change this to 4 by 5. And then you're going to start typing in these numbers. When you type them in, every time you hit enter, it goes across each row before it goes down to the next row. Make sure to be careful that you plug in negatives for numbers that are negative because otherwise this won't work right. After you type in your numbers, you're going to go back to you're going to do second mode, that's quit. And then you're going to go back into matrix again. But this time, you're going to arrow to math. And you're going to look for an option that says RREF. It's probably B. And then you're going to hit enter so that RREF and open parentheses opens on your home screen. Then you're going to go back into matrix for a third time. But this time, you're not going to arrow anywhere. You're going to stay on wherever it is. It's names. And you're just going to hit enter twice until this pops on your screen. This has a special name. It's called the identity matrix. But what you need to remember is that this last column are your solutions. What it's telling you is that A is 1, B is -1, C is 2, and D is -3. So the equation of this cubic function that best represents the data we plugged into the calculator is y equals 1x cubed minus 1x squared plus 2x minus 3. And if you graph your data and you graph this equation, this graph should lie on top of those points, thus being the equation that best represents this data.